Energy storage is one of the biggest challenges for renewable energy, and the most obvious solution seems to be using lithium to store electrical energy, but it's not the only solution, and there are quite a few creative ways out there to store energy that don't require lithium. And in this video I want to highlight one of them called a heat battery, and I want to show you how I built this small scale prototype for my workshop. So recently it's been getting a little bit colder in my workshop, and instead of buying like a regular boring space heater, I wanted to see if I can build something a little bit more interesting, and I wanted to see if I can build a heat battery. Mainly because I want to use this solar panel to basically heat up the workshop, and I want this thing to heat up or charge whenever solar energy is available, and then slowly release that energy over the next couple of hours, hopefully heating up my workshop. The way I'm going to build this heat battery is surprisingly simple. I'm just going to embed this heating element in a block of plaster. But to make it a little bit more interesting, I'm going to 3D print a mold to pour the plaster into. So this is the design I came up with. It's basically a cylinder with a few cutouts to hopefully increase the surface area, making it a bit more efficient at transferring the heat. I'm going to use something called vase mode on my 3D printer. It's basically where it only prints the outside perimeter, and it does it in sort of a spiralized shape so that there are no seams. Alright, so that's done. It looks really good. The only downside is that the print is a bit thin, which might cause a few problems down the line, but anyway, let's go ahead and test our heating element to see if it actually works. Alright, so for the heating elements, I'm gonna use this thing from China. I believe it's meant to like plug into your car and heat a single cup of tea, which is honestly kind of funny, but it's gonna work great for our application because it uses a 12-volt power supply, which is the same voltage my solar panel will generate, and hopefully it is enough to heat up the battery. So I'm gonna snip that thing off and we're gonna see if it works. Okay, I want to see if I can take this plastic housing off, because I don't know if I want that in the heat battery itself, because I don't know how hot that's going to get, so see if I can take that off. So the next thing I'm going to do is I'm going to put some grease into this mold, so hopefully it will release easier and I can reuse this one, but I don't really know. I don't think I'm gonna be able to reuse this mold, but we're gonna try anyway. So I also printed this little disc, and I'm gonna use this to basically insert some legs into it and hold the heating element right in the center. The idea is that this is going to sit right here, and then when I pour the mold, in here, I can just insert this into it, and hopefully when everything cures, I should have 3 mounting points, and the center hole is going to hold the heating element. Alright, now I'm going to mix the plaster. It says about 1 kilo you need 600 milliliters of water. I need a little bit less than 1 kilo, so I'm going to use 750 grams, and that equals about 450 milliliters of water. So I've got this scale right here. I'm just going to use this as a sort of a measuring cup. Perfect. Okay. So that's the water that we're going to use, and now we're going to have to measure out the plaster. Perfect. Alright, now I'm going to go outside to mix it, because I'm not going to do that inside. I also decided to reinforce this thing a little bit. Okay, so it's been about 24 hours. It's dry now. I also added that tape for a little bit more stability, so let's see if it came out any good. Alright, so demolding this thing was kind of a struggle. I had to basically rip open the entire mold, but I did manage to get it out, and I think it came out looking really good. There are a few minor imperfections, but nothing too major, so I'm very happy with the way that it turned out. So the first thing we're going to have to do is weigh this battery to see how much energy it can actually store. And it weighs around, let's say, 820 grams, which is pretty close to what I was aiming for. So let's go ahead and run this experiment. I'm going to use my lab bench power supply instead of the solar panel because it can output a constant power. Solar energy fluctuates a bit too much, depending on clouds and stuff. So for the experiment, I want a nice stable power supply, so that's why I'm using my lab bench power supply. I'm going to set it to 20 watts. And what I want to see is basically how long it takes for this battery to heat up from room temperature, which is around 18 degrees right now, to 33 degrees Celsius, which would mean a 15 degrees Celsius increase in temperature. And given the specific heat density of plaster is around 1100 joules per kilogram, it should take around 13,500 joules of energy to heat up this battery by 15 degrees. I'll put all of the calculations on screen, but at a input power of 20 watts, this should take 11 minutes, a little bit over 11 minutes. Okay, so it's been on for like 15 minutes. Oh wow, yeah, that's hot. That's hot. So in reality, it took about 18 minutes to reach 33 degrees Celsius. We calculated that it should take around 11 minutes in an ideal world. I'll put the calculations on screen, but this gives us an efficiency of about 63%, meaning 63% of the energy is actually stored in the battery. But that doesn't mean that the other 27% of energy is wasted, quite the opposite actually. That 27% of energy obviously went into heating the workshop, which is exactly what we want this thing to do. We want it to work like a space heater. So I also measured how long it took for this thing to cool back down again, and that took nearly 3 hours. And I plotted all these points into this graph, and you can really see that this thing works very much like a battery, because when power is applied, the temperature increases quite rapidly. And then when the power is disconnected, it takes a really long time for it to cool back down, so it really stores the energy over a long period of time. And obviously this is a very small scale prototype, and this thing is not going to heat the entirety of my workshop, but it's a very cool proof of concept, and you can easily scale this up to 100 kilo or even 1000 kilograms heat battery. And depending on how well this video does, I might try building a much larger heat battery in another video. If you'd like to see that, leave a like, a comment, and don't forget to subscribe. But yeah, that's all I have for today, so thanks for watching, see you guys next time.